Hello and welcome to our group's presentation. I'm Michael Holmberg.
I'm Ryan Glove.
I'm Ethan Crouch.
I'm Dan Clancy.
And I'm Evan Keller.
And we're the Krusty
Krushers!
Our group discussed many different ideas in order to create the robot to the best of our ability. While we brainstormed ideas, we had collaborative discussions amongst our group members to pick out the best ideas to accomplish the task. Once our group had agreed on the design, we decided to go with unique choices. We placed the EV3 brick up on its side rather than having it laying down. This will give us plenty of room to work with. Our group had also decided to use a scoop to pick up and drop off the ball. Last but not least, we decided to use a gear system that allows the robot to drop off and pick up the ball.
In order to build the best possible robot, we decided to research the EV3 and the LEGO Mindstorms program. Our group looked at images of previous robots and designs. Then we collaborated and discussed what was best. We also researched gear ratios to figure out how the program was going to run the medium motor to pick up and put down our ball, as well as coordinate with local resources.
Unlike many of the other designs that other groups made, ours was completely unique. We had to rebuild the whole robot entirely, placing the coding block upright on the back half of the robot. The wheel position stayed the same because this was not integral to the design if we were to move them. This was the first thing that we did when we started the project. The second thing that we did was build the scoop. We chose a scoop to pick up the ball off the ground so that we would get extra points on the project. The third thing that we did was made the code using our final robot. And the last thing that we did was simply test the robot and make choices as needed.
Building a robot is the second hardest thing in the morning. Waking up is the first. Third hardest is programming. During programming, we went through multiple different stages and codes. This was the line that we ended on in the end that worked the best. The switch involves a motion sensor and only runs the code necessary to drop and pick up the ball when it senses the wall within 14 inches. The false side of the switch includes the line follow system that uses reflective light values from the white and black on the paper. We got a value in between these two values called the gray value, which was used to guide our robot for it to follow the line correctly. These values were calculated to change each motor's individual speed, and this made the robot more accurate with the line follow system. Overall, the programming portion of the robot involved a lot of trial and error, but we worked through it with our problem-solving skills and our excellent teamwork.
Like multiple projects that we did at STEM, a lot of the project was based in testing. The code was redeveloped by our programmers after it was deleted by accident. This new code went through rigorous debugging and fine-tuning of variables, which resulted in a 99.9% succession rate during testing. The variables had to be changed through the testing process, which made the entire process of fine-tuning a very rinse and repeat process. The testing of different values would find those which were accurate, which would accurately perform our task. Even after testing, we were faced with the issue that was the scooper mechanism. This was perhaps one of the more annoying parts, taking 3 or 4 iterations before it was ready.
In the future, we would like to make a lot of improvements to our robot. The robot itself functions well, but it could have been more aesthetically pleasing. I think that cable management would tie the whole look together. The cables would be concealed, leaving nothing but the brick and the design. During the build process of this project, we realized that our gear system was completely faulty. So, to improve that, we chose a longer axle to move the gear back and forth. This way, the gear was able to connect to the other gear with no problem. The final improvement that we would like to work on was keeping our scooper more consistent. Some of the items on the scooper constantly fell off. I personally had to reconnect the side of the scooper to the frame at least 5 times in the span of only 1 day. We would like to improve the stability and effectiveness of the scooper if we were to rebuild this design.
Thank you and have a great day. Thank you for listening. Have a good one.